We saw a point of intersection earlier in this test where we were able to just, guess and check, take the points that were in the choices and plug them in. We really can't do that here because there's no choices. But also, this is set up differently. And so point of intersection questions are going to more often look like this one, where we're going to need to do some algebra to get the answer. And so there's a lot of steps involved in that algebra. So our best move is always to just be really careful, show our work, don't skip steps, because if we do, we're going to either do a lot of work and get an answer that's not possible, or we're going to make a mistake and never know it, and either way we're losing points or we're losing time. So be careful here. The way to solve this particular one is to use the elimination method. We could use substitution, but elimination is easier. And the goal of that is to make one of the variables disappear so that we can solve for the other. Now, if you're smart, you could see that they want x, so our better bet is to get rid of y. But I think that most people here are just going to do whatever is like the most obvious, I guess. And so I'm going to kind of do it a slightly longer way, but just to show you how all this works. So what you would want to do is multiply one of these equations by some number to make it so that when we add them together, a variable disappears. And so the easiest thing, I think, is to multiply the top equation by -1. Because what that's going to do is it's going to make my x negative, and that'll let it cancel out. But this is what I mean by show your work. What people often forget when they do this method is they forget to distribute that number to all the parts. And when you do that, don't just, draw negatives over what's already written there. Rewrite it. Show your work. So the top equation is now -x minus y equals +9. And I'm going to just write the second equation without any changes, just right below it. Because now I can add these two equations together. And when I do, -x plus x is 0. So the x's cancel out. They get eliminated. That's why it's called the elimination method. 2y minus y is y. And 9 minus 25, here's how I do that in my head. I do 25 minus 9, which is 16. Yes. And then I have to flip it back, so it's -16. Okay, well, what does that get me? Well, now I can take my value of y and plug it into either equation to find the value of x. So I'm going to plug it into the top one just to keep things really simple. So x plus -16 is equal to -9. We add 16 to both sides, and we're going to get that x is equal to 16 minus 9, which is 7, which is the answer. So there we go. Now, if we had eliminated y from the start, we would have just kind of had x, and we wouldn't have to do this last step. But my advice is worry less about where you need to end up and more about whatever is just going to be easiest at the start. I want you to do steps that are less risky. And so in this case, I think that just multiplying by -1 was less risky. The way to get rid of y would have been involved multiplying by -2. And so it adds the negative and the distribution. And so it's just another piece that I could potentially mess up. And so that's how I think about a lot of algebra on the SAT is, can I keep my odds of a careless mistake low? And then hopefully I don't make them. But yeah, point of intersection, be prepared. You're almost always going to need to do algebra. It's a lot of steps, a lot of places where things could go wrong. So show your work, and you should be fine.